Hi there, this is Dr. Sonia, Assistant Professor in Chemistry, SMS College of Technology. We are seeing about the electrochemistry in continuation to the previous video. Now we are going to see about the difference between the electrolytic cell and the galvanic cell. So the main difference are an electrolytic cell, the electrical energy is converted into chemical energy. In galvanic cell, it's just reverse of it. The chemical energy is converted into electrical energy. Okay. And the second difference is the negative electrode in the electrolytic cell is cathode and the positive electrode is anode. And it's just opposite to that of the galvanic cell. That is, the negative electrode is the anode and the positive electrode is the cathode. Okay, and the next main difference is the electrical energy in the electrolytic cell. You have the electrolysis of electrolytes is taking place due to the electrical energy, and in the galvanic cell, chemical reaction causes the development of EMF. Okay, so these are the main differences between the electrolytic cell and galvanic cell. And next, we are going to see about the cell representation. Okay, so the cell representation is an important one where you are going to give the cell, the notation, all the whole of the cell notation in a single reaction. Okay, so by seeing the cell notation, you can tell what type of cell it is and what are the electrolytes and the electrodes that is present in the cell. So here you have, we have already seen about the cell, that is you are having the zinc sulfate and the copper sulfate solution, where in the zinc sulfate you have the zinc electrode, copper sulfate solution you have the copper electrode immersed in it, and it is separated by a salt bridge. So now we are going to write the cell representation of this whole cell. Okay. So first, while writing the cell notation, the salt bridge, you have to represent the salt bridge by a double line. Okay, and you have to separate. You have to take the left hand side and the right hand side, and on the left hand side of the salt bridge that is represented over here, you are going to write the anode. Okay, so the left anode here you are having the oxidation reaction. Okay, always you have the oxidation reaction that is taking place in the anode, and the cathode will be the place where the reduction will take place. Okay. So here the zinc electrode, it undergoes oxidation giving 2 electrons. Okay, so this is the reaction that is taking place in the phase of anode, and you are going to represent it by, first you have to write the electrode. Okay, the electrode in the extreme left corner. Okay, so you have the zinc electrode. It is a solid, right? So I am writing within the bracket as S. Then you have to separate it by a single line, and you have to write the ion. Okay, so Zn2 plus ion, it is the form of aqueous solution. Okay, so this part, the anode part, you are representing in the left hand side of the representation of the salt bridge. Okay, and to the right, again you have the reaction to the right, cathode, you have the copper 2 plus ion. It takes up 2 electrons to give copper solid electron, right? So in the extreme right, you have to represent copper solid, and you have to separate by a single line, and you are representing the copper ion. Aqueous. Okay, so you are representing over here the copper ion. So this is the whole cell notation of this cell. Okay, so from the cell representation, you will get all the information about the salt bridge, presence of salt bridge, about the oxidation reaction that is taking place in the anode, the reduction reaction that is taking place in the cathode, and how they are separated by the lines. And you have the electrodes that is on the extreme corners of the left and the right hand side. Okay, so from this you have to keep 3 points in mind to know this. The electrodes are to be they are placed in the extreme corners. And the second one is LHS, that is the left hand side is the anode where the oxidation is taking place, and the right hand side cathode where the reduction is taking place. And excess 2 half cells is separated by a solid bridge. Okay, so these are the points that has to be remembered in a cell representation. Thank you.